morning. This is a problem in continuous with the DSU series. So this is the first problem. So this is the CSES problem, road construction. So in this problem, we are given with n cities and m roads. So as we going through the input, then we are going to add one new road. So we are given with n initial roads. However, every day a new road will be constructed, and there will be total m roads. A component is a group of cities where there is a road between any two cities using the road. So component is called a group of cities where from each city we can move to another city by using these road. So after each day, your task is to find the number of component and size of the largest component. So what we are going to do is that we are initially given individual nodes, and at every step we are adding one new road between two nodes. So this will reduce the number of component as we are adding new edges between nodes. So in this problem, we need to find number of component after adding each road and size of the largest component. So let's take an example. We are giving n nodes with m edges. So initially we are given n and m. Next we are given with the edges. So let's go through this input. So we are given with 5 nodes. Initially each node is individual node. There is no edge, and we are given with 3 edges. So initially the number of component is 5 and size of maximum component is 1, as all the nodes are initially of component of size 1. So next, now consider first edge 1 and 2. When we add a road between 1 and 2, then number of component decrease by 1. So now number of component is this 1, 2, 3, 4. Then number of component is 4, and size of maximum size component is 2, as this is the component with the number of node as 2, and all the node are component with the size as 1, as each component have only one node. Now so for first, the output is 4 and 2, as number of component is 4 and maximum size is 2. Now let's add another edge, that is 1 and 3. So now again number of component decrease by 1. So now number of component is this 1, 2, 3. The number of component is now 3, and the size of maximum size component is 3. As this is added, then size of this component increase by 1. So number of node in this component is 3. So its size is 3 and maximum size is 3. So next output is number of component 3 and maximum size 3. Now next add next node, that is 4, 5. Again now number of component decrease by 1. So previously number of component was 3, now number of component is 2, and the size of maximum component is, so initially the size of this component become 3, and after adding this edge the size of this component become 2. So maximum of 3 and 2 is 3, so maximum size is 3. So this is the input given the problem. Now let's move towards the solution. So one thing we need to take care of, that whenever we are adding edge, we if edge is adding within the same component, then number of component are not going to be decreased, as if we add a edge between 2 and 3, then number of component again will remain as 2. So this part need to be considered, and that's it. Let's see the solution. So this is the initially template which I already covered in another video. I have made some changes. I have two variable C and mx. So C represent number of component we have currently in the tree. So initially each node will be individual node. So initially the number of component will be n. So when we are performing merge operation, if we are adding edge within same component, then there is no decrease in the component. Else if this is the opposite case, when we are adding edge between two different components, then number of component will going to decrease by 1. So we are decreasing this uh, number of component by 1. Apart from this, we are maintaining an M size, that is representing maximum size component. So initially maximum size will be 1. So initially we are initializing that will be 1. So when we are performing much operation, so in size we are storing the, in each root node we are storing size of its component. So whenever we are updating, merging to component, updating the size of final parent node. And so what we are going to here doing is the size of the smaller component is added into root of the size of the larger component. And after this we are updating the max size. So max size will be updated with whatever initial max size, and after updating, merging to, and what of we are finally getting size, so we are updating this variable. So we need this variable to produce the output, that is number of component and maximum size component currently we are getting. So initially we are given getting number of node and number of edges. So we take the input, create DSU structure, and after we are adding node, we are merging them, and after each merge, we are updating value of C and MX, and we are just updating those values. That is what. I hope this solution is clear. Thank you. Goodbye.